talking about more angle relationships. But these angle relationships are slightly different in that these angle relationships all come back to talking about having a line that intersects two other lines in the same plane. That it does have to be coplanar, but the key thing is a line that intersects two other lines. It's known as a transversal. And it looks something like this. There's a line. There's another line. I'm going to call that one F, that one G. And I'm going to make a line that goes through both of them. I'm going to label it T for transversal. That is the transversal. When I have two lines, and they say it's being cut by a transversal, that's the terminology that tends to be used. When I have two lines being cut by a transversal, 8 angles emerge. There's one, 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 and there's one. Creating a lot of different angle relationships. Now, if the angles share a vertex, kind of like these two do, they are going to be one of the angle pair styles that we talked about yesterday. Those two angles, if it's a little more clear, that means this angle and this angle would be a linear pair. If they share that vertex, it's going to be like yesterday. The other option that it will be is like these ones, which are vertical angles. So you're going to see either vertical angles or linear pairs popping up if they share a vertex. If they don't share a vertex, that's when the new angle pairs come into play. Talking about having one angle from that vertex and one angle coming from this vertex. There are 4 specific type of angle pairs that pop up. The first angle pair that pops up when you have two lines being cut by a transversal, if you're looking at angles that do not share a vertex, would be ones that look like 2 and 6 in this picture. These two angles, they're positioned on the same side of the transversal. In this case, the transversal is the one going kind of up and down-ish, and they're both to the right of it. So if they're on the same side of the transversal, and they're also in the same corresponding part compared to the two lines being cut. In this case, they're both above. Those are what are known as corresponding angles. Which we will shorten down to just CA when we talk about them. The next type is ones like this one's marked with 4 and 5. If I have the two lines being cut by a transversal, and the two angles are on opposite sides of that transversal, angle 4 is to the right, angle 5 is to the left, and they're both between the two lines being cut, they're known as alternate interior angles. Yeah, we shouldn't have our music on right now. If you've got music on, please take your earbuds out. If you have two angles that are on the opposite sides of the transversal, like 1 and 8 are, but neither of them is between the two lines, they're both outside of the two lines cut. In this case, one's above, one's below. Those are alternate exterior angles. Or AEA. And the last type of angle pairing that we're adding today is when the two angles, they're on the same side of the transversal. In this case, they're both on the left side, but they're both between the two lines cut. Those are known as consecutive interior angles. Or CIA. I know. It's almost like that acronym's used for other things. So, when it comes to these 4 angle pairs, if you are trying to identify what angle pair it is, you're essentially going to ask yourself a series of questions. First thing you're going to ask is, do the angles share a vertex? Because if they share a vertex, if they share that corner of the angle, they are not any of these 4. They're either going to be like this and be a linear pair, LP, or they'll be across from one another in these pictures and be vertical angles. If they share a vertex, it's one of these ones. But if they don't share a vertex and you're trying to figure out what kind of angle pairing it is, if they don't share a vertex, it's one of these 4 or it has no relationship whatsoever. To determine which of these 4 it is, you are going to check, first off, where the transversal is and ask yourself if they're on the same or opposite sides of it. That's my transversal, that's my transversal, that's my transversal, that's my transversal. These 2, same side. These ones, opposite side. Alternate, the word alternate specifically means they're on opposite sides of the transversal. If it doesn't have the word alternate, they're on the same side of the transversal. If they are both between the 2 parallel lines, that's what interior means. If they're both outside of the 2 lines being cut like this one, that's what exterior means. And if it's one of each, one's between, one's not between, that leaves us with corresponding. So those are the features you're essentially going to ask yourself. You're going to ask, do they share a vertex? Where is it compared to the transversal? And then the third question is, between the lines, outside the lines, or one of each? Okay, first thing we're going to do is we're going to label the transversal with a T, and then we are going to name the relationship between the given angles. The transversal is the line that intersects the other 2. If I call this, I'm going to actually start down here. If I call this the first line, call this the second line, call this the third line, which line goes through the other 2? The third. That is my transversal. You don't actually have to draw over it like I just did. You just have to call it T. That's the transversal. Okay, now I'm going to ask my questions. Do A and B share a vertex? No. They do not share the corner, which means it's a new style angle pairing, if anything. Are they on the same or opposite sides of that transversal? Opposite. One's to the left, one's to the right, which means it has to have the word alternate if it has a name at all. Alternate comes in interior or exterior format. Here are the 2 lines being crossed. Are A and B between them or outside of them, or is it one of each? Outside of them. Outside is exterior. Opposite means alternate. They are alternate exterior angles. I'll move on to question 2. That's start from the bottom. Line 1, line 2, line 3. Which one's the transversal? 1, 2, or 3? 1. Label it with T. Now, I do tend to highlight it because it makes it easier to see, and that's important. Okay, do A and B share a vertex? Do they share the pointy part of the angle? No. A's vertex is there, B's vertex is there. Are they on the same or opposite sides of that transversal? Same. They're both to this side of it. So, same side of transversal means it either has to be corresponding or consecutive interior. Are they both between, outside, or one of each compared to the two lines being crossed? Here's the between part. They're both between. Same side of transversal and between is consecutive interior. Okay. Line 1, line 2, line 3. Transversal is 1. Do A and B share a vertex? No. Are they on the same side of the line or opposite sides of the transversal? Same. So, same side of transversal means either corresponding or consecutive interior. Has to start with a C when they're on the same side of the transversal. Are they both between the two lines cut, outside of the two lines cut, or is it one of each? One of each. Same side of transversal. One interior, one exterior is corresponding. Sometimes they're going to throw something at you, or throw a wrench into things, and they'll give you a picture like this. My angles are A and B. This angle and this angle. If I draw in the sides of that angle, do you notice that that line doesn't get touched? It's there to throw you off. Ignore it. Scribble it out if you need. So, once we've scribbled that out, which one is the important transversal? Because there's actually multiple transversals in this picture. We want the important one, the one that doesn't include anything to do with this line. 1, 2, or 3. Label it with the T. Okay. Do A and B share a vertex? No. So, new style angle pairing. Same or opposite sides of the transversal? Opposite, because here's the transversal. One's to the left, one's to the right. Interior, exterior, or one of each? They're both outside of the two lines cut. Opposite sides exterior is alternate exterior. One, 2, or 3? 1 is the transversal. Do A and B share a vertex? No. So, new style angle pairing. Same or opposite sides of the transversal? Same, they're both below it. Interior, exterior, or one of each? Are they between, outside, or is it one of each, in other words? They're between. Between is interior. Outside is exterior. So, same side and interior? CIA. Okay, last one that is a pure identify, and then we're going to get to doing some solving with this today. One, 2, or 3 is a transversal. 1. Do A and B share a vertex? Yes, which means it's a new style, or an older style angle pairing, as in like a yesterday angle pairing. It's that angle and that angle. Linear pair and vertical angles are the only options it's going to be. Are they across from one another or next to each other? Across. Across from one another, creating an X. Vertical angles. It is also possible to have angles that don't have a relationship. I didn't give an example of those here, but it is possible to not fit any of these, and you just write none. Now, here is why we talk about these angle pairings. Because much like yesterday we came up with the linear pair postulate that said linear pairs are supplementary, and the vertical angle theorem that said vertical angles are congruent. There is a relationship with corresponding alternate interior, alternate exterior, and consecutive interior angles. If you have corresponding angles, they are congruent. When you technically have two lines cut by a transversal, and the transversal's right here, there is more than one pair of corresponding angles. There's numerous pairs. Corresponding requires they be on the same side of the transversal, one interior, one exterior, don't share a vertex. So, let's start with angle 1. If, and here's the key thing about this, and I almost forgot to say it. If parallel lines, that's what that symbol means, by the way. It's parallel. If you have two parallel lines being cut by a transversal, then these relationships hold true. If they're not parallel lines, it doesn't do any good. By the way, that's how you show parallel in writing. This has how you show parallel on a picture. They've got the little triangles. If two parallel lines are cut by a transversal, the corresponding angles are congruent. Corresponding angles can include angle 1 being congruent to, so corresponding, same side of transversal, one interior, one exterior. Angle 1, if I'm going same side of the transversal, I've got 3, 5, and 7. Which one is going to correspond with it? 5, because it needs one interior, one exterior, but it can't be right next to it. So angle 1 would be congruent to angle 5. That's one pair of corresponding angles here, but there's more than that. Or, if I was talking about angle 2, I'm going to get rid of some of that. 2 would correspond with 6. Are there others? 3 would correspond with 7, and 4 would correspond with 8, which means we could say angle 1 is congruent to angle 5, angle 2 is congruent to angle, it was 6, or angle 3 is congruent to angle 7, or angle 4 is congruent to angle 8. Corresponding is the most common occurring. And if you see this, if you see parallel lines being cut by a transversal, you can say that they are congruent by the corresponding angles postulate. We also have alternate interior angles. Alternate interior angles also happen to be congruent. Alternate means opposite sides of transversal. Interior means between the two lines. So we could start with like angle 3. Angle 3's alternate interior angle would be angle, not 5. 5 is on the same side of the transversal. I need the opposite side. 6. Or you could also reference angle 4 being congruent to angle 5. 4 and 5 are alternate interiors. And that's using the alternate interior angle theorem. Again, this only works if the lines are parallel, but we're working with the same picture. Alternate exterior angles also happen to be congruent. Be careful, consecutive interior angles are not congruent, so don't get ahead of yourself and do that one. Alternate exterior angles have to have an exterior, so I could start with like angle 1. Alternate means opposite sides of the transversal. So 1 would go with 1 and 2 are a linear pair. They share a vertex. I have to go down here somewhere. 8. Opposite sides of transversal and both outside. Or I could also have referred to angle 2 being congruent to angle 7. Good. And that's the alternate exterior angle theorem that's telling us that. The last theorem is different. Consecutive interior angles is different. The theorem itself follows the same path, CIA, and it's a theorem. Consecutive interior angles are supplementary, though. Consecutive means same side of transversal. Interior means between the lines. So I could start with angle 3. And this one you have to write and. Angle 3 and. 3 is consecutive interior with what other angle? Cannot share a vertex, otherwise it's an old style, so 1, 2, and 4 were out. Consecutive means same side of transversal, which means 6 and 8 were out. I was down to 5 and 7. And interior means both between. So 5 and 7, or sorry, 3 and 5. So angle 3 and angle 5. And this one we say they are supplementary. That's not the only pair. There's one other pair of consecutive interior angles. Angle 4 and angle 6 are sub. So if we have parallel lines being cut, we have the ability to solve that. We got one final page that we're talking about. We're doing the actual solving. So, the instructions say threefold. Label the transversal T, identify the angle pair, solve. Okay, 1, 2, 3. Which one's transversal? First one. Do these two share a vertex? No, which means they're one of the newer ones, one of the ones from today. They don't share a vertex. Are they on the same side or opposite sides of the transversal? Same side. Are they interior, exterior, or one of each? Interior. Same side of transversal and interior is CIA. According to the consecutive interior angles, when I have parallel lines, are the lines parallel? How do you know? The little triangles. When you have parallel lines cut by a transversal, are consecutive interior angles supplementary or are they congruent? CIA is supplementary. What does supplementary mean? They add up to 180. So, the 141 plus the 16 plus the x will add up to be equal to this. If I want to solve an equation like that, what am I going to do first? Combine like terms. If this was a proof, what's combined like terms called? Simplify. 141 plus 16 is 157. Still plus an x equals 180. And then I'm going to subtract the 157 from both sides. And I'm going to get 23. Question 8. 1, 2, or 3. Which one's the transversal? 3. Do these two angles share a vertex? No. So it's one of the 4 from today. Are they on the same or opposite sides of the transversal? Opposite, because this is my transversal. One's left, one's right. Opposite sides of transversal. Are they interior, exterior, or one of each? Interior. Opposite sides, interior. Opposite sides means starts with an A. Alternate. Interior. Alternate interior angles. Are alternate interior angles of parallel... Wait, are the lines parallel? are alternate interior angles of parallel lines congruent or supplementary? Congruent. According to the alternate interior angle theorem, we get congruent. Congruent's a fancy way of saying what? 126 is equal to 4x plus 2. Do you trust my solving skills?
Yes.
X is 31. For the sake of our notes, we're going to that. Question 9. I got extra lines, which means one of these is here to throw me off. The bottom one as in like the bottom arrow or the bottom? Yeah. This one. It's not creating either of my angles. My angle use this and this. That's that line, and this line. Okay. 1, 2, or 3 is the transversal. 3. Label it with a T. Do those two angles share a vertex? No. Are they on the same or opposite sides of the transversal? Here's the transversal. They're on opposite sides. Are they interior, exterior, or one of each? Exterior. When you're looking interior or exterior, if we ignored a side, make sure you continue to ignore it. Opposite sides and exterior? AEA. One of the most common things that I see is people struggling to identify the angle pair. If you are struggling to identify the angle pair, line up your picture as best as you can with the picture that's on page 6. Try to kind of line up that transversal specifically. If it doesn't line up nicely this way, spin it around and see if it lines up better this way. That 40-degree angle is kind of in the position of angle 1. This 10-degree or 10x angle is in the position of angle 8. If I recognize which two it's pairing up with, 1 and 8, then I can check my list and see where are 1 and 8 together. Right here, they're alternate exteriors. If that helps you, go ahead and do that. Anyway, are alternate exterior angles congruent or supplementary? Congruent, so I set them equal x is 4. Question 10. That's my transversal. They do not share a vertex. Are they on the same or opposite sides of that transversal? Opposite. Are they interior, exterior, or one of each? What kind of angle? Alternate interior angles. Alternate interior angles. When the lines are parallel, that's the key thing. Congruent. Therefore, set them equal. Here's my transversal. Are those angles on the same or opposite sides of it? Same. Interior, exterior, one of each. One of each. And they do not share a vertex. This one goes to this corner. CA, corresponding angles, which are congruent. 11x plus 9 equals 10x plus 20. X is 11. I am quickly wanting to go through all of these because it's one of the biggest things that we talk about. Which which line is here to throw me off? Which means this is my transversal. They're on the same side of it. They don't share a vertex. What kind of angle, Perry? CIA, consecutive interior. Which means it adds up to 180. Consecutive interior angles are not equal. Every single time I do this, at least one person tries to set them equal. Be careful with that. X is 29. Yeah, we could probably skip the last two. We've already come across what's with the last two. But I wanted to at least get back to that because, yes, we did a CIA first, but just to remind you to check supplementary or congruent. The stuff we did yesterday and today is building the main stuff that we do in this chapter. If you are getting stuck on things, please make sure you are asking questions. I already told you, this entire chapter is worksheets.